Hi, this is Andreina Castillo, and this is Lab 9, which is the Physics of Extreme Sports with Ropes, Part 2. The problem and the main objective of this experiment was developing a Python code that would resemble the physics of sports that involve ropes, such as bungee jumping or the rope swinging that we analyzed in this part. The questions we want to solve is what's the physics of sports with ropes, what forces act on rope swinging, and how are energy and momentum principles applied to this situation. The main results found after performing this project is that the Python model developed is a close resemblance of the motion of the mass of the analyzed video that was given to us in WebAssign. Here's the tracker video I did of the spring and the mass, and you can see how the motion is rather uniform in both the x and y direction, and even though it's longer than the others, the motion keeps on going around the same shape. Now here is the Python model in the x-axis and the y-axis, and here you can see the periods of the movement, while in the tracker analyses it has more periods, but that's only because the time it ran is longer than the Python model. Now the three questions that we have to answer for what does it mean is the first one, the period of oscillation. Here in the x direction we can see that the period is shorter than the y direction, and that's mainly because the force of gravity is added to the y direction change of the mass, so that makes it go faster in the y direction, so the period decreases and the object moves faster along that axis. The second question was the change of system, changing the system from only the mass to the mass and the spring, and that changes the effect surroundings have on the system. Having basically no surroundings makes the change in energy equal to 0 or work equal to 0. So that develops the need for a potential energy of the spring, and changes the formula we had previously for work. So basically, if we include the spring on the system, the work goes to 0. And the third question was the location of the origin. If we move the origin in the tracker video from where the spring is attached to the wall to the equilibrium position, the change in energy is here the blue line, which is 0 or constant. And that's what we expected, because if we bring it to 0 and include the spring's potential and the spring and the mass in the system and work equals 0, the line has to be flat. Thank you for watching, and I hope you enjoyed it.